let's talk about combinations, and these are very pervasive. All right. So the setting here is we have n distinct objects taken k at a time, but order does not matter. In other words, we're looking at the number of subsets, S-U-B is how you spell sub, subsets with k elements. So the difference between the Dr. T's fan club, and maybe that's going to come here. Oh, that's number 13. We have 20 people in the room, and I want to take them 5 at a time. Well, I don't really care if I pick myself first and then Gabe and then Dave, or Dave first, then Gabe, and then me. I just need 5 people to go. There's no sort of preeminence in our club here. So that's the difference between when we had a first, second, or third kind of case. Lauren?
Does the distinct objects part of the definition imply there's no replacement?
Right. Yes. Yeah. And we'll do an example where there is not distinct objects up here shortly. So whose name? Oh, what's the counting formula? Well, it's going to be n factorial over n minus r factorial. That's our permutation, but then we just have to divide out by the number of different arrangements those r elements. And so that would be r factorial. In other words, it's like ABBA. It's the ABBA problem here. We have 4 distinct objects, A, B, B, A. We take 2 of them, but then we have to divide. We have to divide out by the number of ways we could arrange the B's and the number of ways we could arrange the A's. Whose name is associated with this one? Give you a hint. He's the quote of one of the quotes here on the first floor. Actually down. Yes, Pascal. That's right, Blaise Pascal. Christian. And someday, if you haven't already, you should read his anyway, however you pronounce it correctly, which is pretty good. So, if our objects can be selected without order mattering, so it doesn't matter, then it's going to be n factorial over n minus r factorial over r factorial. And the way we write this as n choose r or n choose r. So now let's go back to Katie and Lauren. In this case, they just need to make a committee for Dr. T's fan club. Have 6 students available to them. And so that would be 6 choose 3. In other words, 6 factorial over 3 factorial over 3 factorial, and that's actually 20. And by the way, you can do this on your calculator by hitting 6 and then going to the math and over to the probability and down to number 3 to NCR and hitting the 3 again, and you get the 20. I don't know if your calculator writes it as 6, NCR, and then a 3, or you put the lower things on there. Abby?
How is this like the ABBA problem then?
Oh, what happens is we have 4 objects available to us, and I've got to pick 2 of them.
No, so you're not talking about the order of A, B, A, B, you're talking about, I have two A's, I'm gonna pick an A and I'm gonna pick B.
Yeah, I'm gonna pick, this guy gets picked, this guy gets picked, this one doesn't, this one doesn't. So that's 4, choose 2. So it's like picking the blanks for my set. Okay? So I have 4 distinct blanks. I'm going to pick 2 of them to be in my group and 2 to be outside the groups. If I flip 8 coins, 1, 2, 3, 4, 5, 6, 7, 8, and I want to count the number of ways I can get 6 heads, I'm going to pick 6 blanks to be the heads and 2 to be what's left over for the tails. So this is going to be 8, choose 6. Number of different ways I could do that. So I have 8 places and then 6 H's and 2 T's. Mitch?
So for when you're choosing and you're writing it out, for odd numbers or even even numbers, you have to have the denominator, I guess, without the factorials add to the numerator. So like
Yes, yes, that's right. So 6 plus 2 will be equal to 8. I mean,
Like, if you're following this formula, you would do n factorial over n minus r, which is 6.
and then you divide by the r factorial, which would be 2 factorial.
So how do we,
I'm sorry, it'd be the other way around. It'd be, if you did this one, it'd be 8 minus 6 would be 2 factorial, and then the r factorial would be 6 factorial.
oh, because r is the 6.
Yeah. Now, while we're here, we might as well talk about this. If I have 6 places to choose the heads, how many places could I put the tails?
2.
And so in this case, 8 choose 6 is the same thing as 8 choose 2. Another way of saying it, the number of ways to choose these objects is the same number of ways to not choose the other objects. Like the these stacks. Sneeches. Other questions? All right, so here is good old Pascal's triangle. Oh, let's go to the k choose n. If I choose all of them, I get n choose n, which is equal to 1. There's only one way to choose everybody. How many ways can I choose nobody? 1. If I just choose one person, I get n different ways. And if I choose everybody but one person, there are n ways to leave them off. So what we have here is, and maybe I'll just write it on, I think I'll mess up this part here. So you can decide if you want to write it next to that one or on your opposite side of your page. But what Pascal's triangle is the following. The very top is 0, choose 0. Then I've got 1, choose 0, and 1, choose 1. 0, choose 0 is kind of the tricky one, so you may not think about that. So this is 1, choose 0, which is 1, and 1, choose 1, which is 1. And the next one is 2, choose 0, 2, choose 1, 2, choose 2. So 1, 2, 1. And then 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3. 1, 3, 3, 1. Yeah, the thing about Pascal's triangle is that to get this next value, what you do is you add 3, choose 0 plus 3, choose 1, and you get the 4. To get 4, choose 2, I would add 3 plus 3 and get 6, and then so on. So for example, what would this 35 be right here? What is?
7, choose 3.
Yes, this is 7, choose 3 right here. And this 15?
6, choose 4.
0, 1, 2, 3. Yeah, 6, choose 4. Right. By the way, what is the sum of each row? The first one is Second one is, and then 4, 8, 16, and so forth. You could kind of see that by how this relates to x plus y squared. Remember, x plus y squared would be x squared plus 2xy plus y squared. Do you remember this from pre-calculus class, how you multiply this all out? If you multiply x plus y cubed, you get x cubed plus 3x squared y plus 3xy squared plus y cubed. So notice the exponents of the x's go down by 1, and the ones with y go up by 1.
Also the coefficients.
And the coefficients correspond to 1, 3, 3, 1. And you can kind of think about it as, suppose I want to get 2 x's and 1 y. I'm back to the ABBA problem, right? I've got x, number of different ways that I can pick an x, and then a y, and then an x, or y, xx, or xxy is 3 different ways. And so it's like picking one of these variables, it just has to add up the 3 in each case. And that's another way of thinking about how that great coefficients for your algebra ends up working. Let that sink into you again. So for example, if you have x plus y to the n, well, we'll pick that up a little bit tomorrow. Was Pascal the first one to create this triangle? No. Egyptians, Chinese, Indians, lots of different places. And so it's difficult to know who was even first. All right, let's take a look at number 14. You're taking a sample of jurors and you want them to be all female. Well, altogether, you're taking 9, choose 3, because there are 9 possibilities. If I want them all to be female, I would do 3, choose 3 times 6, choose 0. That gives me 1 times 1 over 84. Well, I've got 3 females, I've got to take 3 of them. So that's 3, choose 3. And then I take the males, I have 6 males available, I don't take any of them. And then altogether I have 9 people, I'm going to take 3 of them.
How is this different than like when we're finding
You get the same answer, right? We're just looking at a different way. And one of the great things about mathematics, if you just take different perspectives and you get the same answer, that gives you more confidence. In some sense, it is the multiplication principle, because we're going to take the females first and then the males. So let's suppose that we take 1 male and 2 females. Yes?
That is not the same as what we got before, though, is it?
Wasn't it we get 1 over 84?
Yeah, it's what I do.
Well,
We didn't get 1 over 84?
I think it is. It is. 9, choose 3 is 84.
is this on page 24, number?
Making it simply.
There we go.
Number 11A. 11A.
Please
There's 2
disregard my
different ones we
comment.
did.
Okay. All right, let's do 1 male and 2 females. For females, I do 3, choose 2, and for the males, 6, choose 1, over 9, choose 3, and I got 18 over 84. I'm going to keep them in 84th because that works okay for me. So 3, choose 1, 6, choose 2, over 9, choose 3. I get 45 over 84. And then all males, I take no females, take 3 males, over 9, choose 3, and I get 20 over 84. Okay? And the probability of at least one female means I have no females. So 1 minus 20 over 84 gives me 64 over 84. All right. Oh, we didn't get the time permitting part. We'll pick up some things on Wednesday, because tomorrow, come at 11 if you signed up, and come at 12:15. Okay, have a good day. You could probably show up at 12, just, we can't have, just make sure we don't have too many people in there at once.
Should I just show up at 12 then?
Either one.
Okay.
Like the full game for graphics, like everything is important, but it is identical to graphics, everything. Yeah, as if you're playing. Because these things are so powerful. And technology. Well, the computers at DOS are like, like your 6502, that's a little older, but, think about, those are kind of nothing. They're like modern.